Hello dear viewers, welcome again to another informative video. This is your host Mr. Mono Surfer and I am here to give knowledge and make you more valuable. Ever wonder how satellites get launched into space? In this video, we'll take you through the process of launching a satellite, from the initial assembly of the satellite and its rocket, to the fuel selection and launchpad integration, to the actual launch itself. To the fuel selection and launchpad integration, to the actual launch itself. We'll explain the principles of rocket thrust and Earth gravity that make a successful launch possible, and discuss the importance of selecting the right launch site for optimal results. This video is perfect for anyone curious about how satellites get launched into space. But before we begin, did you know that there are over 8,261 active satellites orbiting the Earth right now? These satellites are used for a variety of purposes, from providing us with GPS navigation and weather forecasting, to helping us communicate and even take pictures of the planet from space. From the initial assembly of the satellite and its rocket, now, let's talk about process of launching a satellite. Step 1. Design and assembly of the satellite. This includes designing the satellite to meet the specific requirements of the mission, and then assembling all of the components together. Step 2. Testing. Once the satellite is assembled, it undergoes a series of tests to ensure that it will function properly in space. This includes environmental testing, such as vibration and thermal testing, as well as functional testing of the satellite's systems and subsystems. Step 3. Integration with the launch vehicle. The satellite is then integrated with the rocket that will launch it into space. This includes attaching the satellite to the rocket and performing final checks to ensure that everything is functioning properly. Step 4. Transport to the launch site. The satellite and rocket are then transported to the launch site, which is typically a spaceport or a launch range. Step 5. Countdown and launch. The final preparations for launch are made, including fueling the rocket and performing final checks. The countdown to launch begins, and the rocket is launched at the designated time. Step 6. Deployment. After reaching orbit, the satellite is deployed from the rocket and begins its mission. The process can take several months to several years, depending on the complexity of the satellite, the nature of its mission, and the availability of launch vehicles. A successful launch of a satellite or any other spacecraft is made possible by the principles of rocket thrust and Earth gravity. Rocket thrust is the force produced by the propulsion system of a rocket that propels it forward. The thrust is generated by the combustion of a fuel and an oxidizer, which creates hot gases that are expelled through a nozzle. This creates a forward force, or thrust, that opposes the weight of the rocket. The greater the thrust, the greater the force pushing the rocket upward, and the faster the rocket can accelerate. Earth gravity, on the other hand, is the force that pulls the rocket and all other objects towards the center of the Earth. For a rocket to successfully launch, the thrust must be greater than the force of gravity pulling it downward. Once a rocket has enough thrust to overcome gravity, it will begin to accelerate upward. As it gains altitude and speed, the force of gravity acting on it decreases, which means the rocket can continue to accelerate at a faster rate. Eventually, the rocket will reach a speed and altitude at which the force of gravity is no longer enough to pull it back to the Earth, and it will enter orbit. Once the satellite is in the orbit, it will continue to be affected by the Earth's gravity, but it will also be affected by the centrifugal force that opposes the gravitational force. This centrifugal force is also known as the centrifugal acceleration, which is a result of the satellite's motion in orbit around the Earth, which keeps the satellite in orbit. Once in orbit, the satellite's solar panels are deployed to generate power, and it begins to communicate with ground stations on Earth. Interesting fact. To reach the minimum altitude required to orbit the Earth, the space shuttle must accelerate from 0 to 8,000 meters per second, almost 18,000 miles per hour, in 8.5 minutes. Satellites use radio waves to transmit and receive data, and they are equipped with antennas to do this. These antennas are often pointed towards the ground station on Earth, in order to establish a communication link. Rocket fuel is typically a combination of a fuel and an oxidizer. The most commonly used fuels for rockets are liquid hydrogen and liquid oxygen, as they have the highest specific impulse, a measure of the efficiency of a rocket propellant. Other commonly used rocket fuels include kerosene and hydrazine. Now let's understand the importance of launch site for successful launch. Geography and weather. The launch site should be located in an area with minimal environmental hazards. Facilities and infrastructure. The launch site should have the necessary facilities and infrastructure to support the launch. Access to the desired orbit. The launch site should provide the ability to launch the satellite into the desired orbit. Cost. The cost of launching from a particular site should be considered, including the cost of transportation, facilities, and insurance. Some of the most well-known launch sites include Cape Canaveral Air Force Station and Kennedy Space Center in Florida, USA. Guiana Space Center, CSG, in French Guiana. Baikonur Cosmodrome in Kazakhstan. Tanegashima Space Center in Japan. Xichang Satellite Launch Center in China. Satish Dhawan Space Center, Sriharikota, India. Do you know, friends, that Moon is the natural satellite of the Earth? Over the period of Earth's creation, many asteroids and meteorites bombarded Earth, which resulted in all of the broken Earth's parts started revolving around it, because of Earth's gravity, and resulted in today's Moon. Now, let's talk about the different types of orbits that a satellite can be in. There are three main types of orbits: low Earth orbit, medium Earth orbit, and geostationary orbit. Low Earth orbit, or LEO, is the closest to Earth and is typically used for applications such as the International Space Station and spy satellites. Medium Earth orbit, or MEO, is used for navigation systems such as GPS. Finally, geostationary orbit, or GEO. It is a type of orbit where the satellite is always in the same location relative to the Earth. This is ideal for communication satellites, as it allows for a stable connection to be maintained. Satellites have changed the way we live, work, and communicate. They are responsible for the GPS in your phone, the weather forecast on the news, and even the pictures of the Earth from space. Satellites have become an integral part of our everyday lives. And it's exciting to think about what the future holds for this technology. Thanks for watching, and we hope you've learned something new about the exciting world of satellite launches and how satellites work.